Dr. J. Mohan. I am from Institute of Aeronautical Engineering. Today we discuss about the signals and forecasting subject in the subheading of conditional distribution. Topic is going to map with CO4 in the subject as COPO mapping. The CO4 is extend the random variable concept to random process, and it is sample function for demonstrating the time domain and frequency domain characteristics. And the programming outcome is mapped with PO4. The name of PO4 is range of configurate requirement. At the same time, the sustainability goal is mapped with 3. One is quality education, affordable and clean energy, climate action. These 3 are mapped with conditional probability condition topic of signal and stochastic processing subject. Today presentation outline is conditional probability in the case of properties. In this we discuss about the definition, descriptive properties, mathematical property, related distribution, as well as the application area of daylight distribution in the conditional distribution. First we go for the conditional probability. What is the conditional probability? The conditional probability is represented as a probability of events that occur given in the another event has already occurred is represented as a conditional probability. The conditional probability, the event we measured as capital letter of E, and the event has occurred already is measured as F. So that's why we call mathematically as probability of E in the probability event in slash of already occurrence is represented as a capital letter F. It's equal to P of E into F divided by P of F. The P of E into F is the probability that both events E and F likely find the overlap between the two circular in the Venn diagram. For example, if we take for the P of E in the probability of occurrence in the events condition for the conditional cases, we go for the two events, one is A and B, both it will be going to overlapping together. That overlapped case we call for the overlap between the two circles in the Venn diagram. We will discuss in this case is later. Next, we go for the P of F. This is the just the probability of E1 F, and it is important that P of F is not 0 because of we cannot derive by the 0. The P of F not 0 condition, in the overlap between the two Venn diagram circle, it's not getting the 0. That condition we represent as a P of F not is 0. See here, we shown the Venn diagram here. See the event E and the occurrence of overlap between the two events is represented as a F. Okay, so this is a Venn diagram. We call for the P. This P is happen for one event and overlap happen for the P of F another event. Both it will be overlap together. That is called for the E of F. E of int F. We call for the E of int F. This area. So what will be happen? This is the events also is there in the Venn diagram. At the same time, overlap occurrence also is going to have in the Venn diagram. This portion we call for the E of in F. This is the ratio of the change the both E and F happen on the changes that F occurs. So this case P of E is not a 0. That's what we say that here P of E or P of F not a 0. So this Venn diagram overlap between the two circles in the diagram. That is called for this one. For example, we take for the image of A, B, C companies. A about 20% of the employee earn more than of 50,000 per year. Also, 20% of employees are college graduated and 50% employees are in the college graduated earning more than of 50,000 in a year. Okay, we get for the one company name. This company name, 25% of employees are earned 50,000 a year, and in this case 20% of employees are college graduated and 50% of employees are graduated earning more than of 50,000 a year. So what will be happen? The company is going to pay for the 50,000 a year of salary. In this case, some of them is graduated, some of them is graduated. They are waiting for the more than of 50,000. That is an example. What we say for B, we are trying to figure out for the P of HC. Okay, H is event. The employee earn more than of 50,000. Okay, I take H is event that employees earn more than of 50,000. C is the event that employee is college graduated. Two events I take. One is H and C. H is represented as a employee more than a 50,000 salary, and the C is even the employee is college graduated. Now I make to do for the events. So what the event? P of H. What will be represent? P of H is a employee earn more than a 50,000 salary. Okay, they earn more than a 50,000 salary. That means in the sum they are given for us 25% of employees earn more than a 50,000 salary. I take this one as a P of H. 25% of earn more than a 50% salary. That means 25% in the sense will be called for the 0.25. And another one is the graduated. So here the graduated is 20%. College graduated. In this case, what will be happen? 20% is called for the 0.20. That is called, we called 20% are college graduated. Next, we go for the difference between the P of H and C. The P of H and C difference I represent as a P of H and C is equal to 50%. It may be they are graduated or non-graduated. Okay, they are getting salaries more than a 50,000. If some of them have the more experience, they are getting more salary. Some of them is college graduated, even though they are getting for the more than a 50,000 salary. They are going to be placed. So that percentage is represented as a 15%. Okay, that percentage is 15%. So the 15% are graduated earning more than a 50,000. So now we need to find out for the event occur, the conditional event occur. What the conditional event? We taken for the P of HC. The P of HC, the conditional event, we know the formula of conditional event as P of E plus F is equal to P of E into F divided by P of F. So that is called for the conditional property. We apply for this conditional property in the industrial case of employee condition. So P of H into C divided by P of C. So that is called for the 15% of employees earned more than a 50,000. There is possible to have a graduated or non-graduated. Then P of C is the graduated peoples are getting for the 20%. So we get for the 0.15 to 0.20. we get 0.75. Okay, the 0.15 divided by 0.20 is 0.75. Now, the probability that the employee earn more than a 50,000 salary, this is the case. The graduated people are 75%. Okay, this is given that they are college graduated is 75%. So, if someone is the college graduate, there is high chance that they earn more than a 50,000 salary. That's true. Okay, this is representing conditional cases. If he graduated, they are getting for the more salary, or if not graduated, they have more experience in the company, they are getting for the more than a 50,000. So if not have the graduated, they are getting for the very less amount of salary. That is the case of condition. We can find out easily what the requirement based on the condition they are going to. So nowadays we are going to developing for the machine learning algorithm. This machine learning algorithm is going to easily predicted for the salary of employee without doing for the prediction, without doing for the human prediction. The machine itself. So it's going to predict. We give for the experienced person. Experience I represent for the E of X. Graduated we represent as a G of C, and graduated with experience and C. Okay, graduated as well as of this case. If you have experience more than a 10 year, they're getting for the good salary like 50,000. We consider. Okay, if graduated with 1 or 2 year experience, they're getting for the 50,000 plus some incentive. Then graduated with experience, then 50,000 plus incentive plus based on the experience. Okay, so now this one it will be going to write for the program we are using for the any machine learning algorithm like supervised case or non-supervised case or reinforcement case condition. We can predict based on the person, based on the employee for the salary statement. Okay, so how it will be given for the increment, that and all we use for the conditional probability condition. Okay, this is going to real application next. The conditional probability with equally likely outcome. What's the meaning of equally likely outcome? What the exact position equally is possibility of condition, that is called for the equally likely outcome. So the conditional probability gets a bit similar when all outcome and experiment are equally likely. The equally likely probability outcome I represent as a P of event and overcome. Okay, P of E and overcome is equal to number of outcome in the difference between the events as well as of overcome divided by number of outcome in the overcome. Okay, so simply we called P of E plus of F is equal to number of outcome in event as well as of overcome as well divided by number of output of overcome. Okay, it's how for the rules. That rule is called for the product rule. Okay, the product rule is represented as a conditional probability only. That's what I may use for the conditional probability. It's help to calculate the probability of both event as well as of overcome or happening. We write as a P of E in F is equal to P of F into P of E into F. Then it's going to satisfy for the independent probability. The independent probability is said that unrelated or separated of event is represented as independent. That's what I mentioned here is independent means something like unrelated or separated. We have the two event. One is E as well as of F. The E is a event of occurrence, F is represented as a over outcome. So both are independent if knowing that one event is occur does not change the probability of other event. Okay, so the event and overcome, both it will be not overlap together. That means does not change the probability of other events. The E and F are independent. I write as P of E into F is equal to P of E into P of F. Okay, this is the way we are made to represent. The P of E and F is equal to P of E and P of F slash E is equal to P of F. So both it will be represented as a overlap together, even though it's represented as a independent together. If E is a event is overlap between the F event, then I write as a P of E. If overlap is occur into independent event, then I write as a purely probability of overlapping or overcome. So this is called for the independent. So it's going to have further two type of events. One is represented as a product, another one is represented as a independent in the conditional probability. Then we go for the independent multiplication event. So here let's have for the two event is occur. One is like independent of set of events. In other event, I take for the case of overlap between the event as well as of two event. That's why I specify for the three event. One is represented as a event, that is I represent as a E1 and E2. The overlap is represented as a event, that is a independent, that is called for the E3. We say that the independent of the occurrence of one event does not affect the others. I write P of E1 and P of E2, E3 is equal to P of E1 into P of E2 into P of E3. This is a way we may represent. This reference we take for the second condition, or the second condition, independent probability condition. Okay, the independent probability condition, it's always make as a multiplication of both event as well as of overlap. So if we happen for the multiple case of events, here I take for the three events, that is E1, E2, E3. Suppose we take for the n events, that is N1, N2, N3. Then probability condition P of N1 into P of N2 in up to will be have the into N of N. Okay, up to this is N of N. It will be have. So this value is represented as here P of N1 into P of N2 up to into P of N of N. Okay, this is N of N. So if have independent events, all it's getting to the multiplicative activities. Okay, this three cases is very, very important for conditional probability. Next we go for the conditional probability distribution. Conditional probability distribution always is going to occur as a event based, as a prior knowledge of another event. That's why I defined as a conditional probability, defined the probability of event occur based on the given condition or prior knowledge of another event. I take for the two event. This is represented as A and B. So it can be expressed as P of A and B. This indicates that the probability of event when the event B has already occurred. Okay, is represented as a conditional cases. So A and B is going to take the two event. I represent for the conditional case of as a mathematical P of A and B. It's independent cases. It's indicate the probability of event A when the event B has already occurred. That means overlapped. This two event A and B, we make for the formula for conditional probability of A when B has already occurred as an event. Then P of A B is equal to P of A, difference of B divided by P of B. Suppose B is happen. Okay. Suppose we have further B is happen. B is a event and the overlap between the A. It is represented as a P of P, difference between the A divided by, we take for the P of A divided by P of A. We can write it for any way for in the conditional property. That's what, if the conditional property is flexible to any cases. So here P of A difference between P of B or P of A in P of B represents the probability of both event A and B occurring simultaneously. P of A represents the probability of event A occurrence. Okay. What are the steps to follow to find the probability of events? First step, the case one event is given and another event is already occurred. In the case, first step, identify for the event. For the events. So we take for the two events, A and B. We take for the event of A and B. After that, we determine the probability of both the event. One is event A, I write for the probability of A. Another event is represented as a event B. The probability is equal to P of B. Next, determine the difference between the both the events. That is, I represent as a and B. Determine the probability of difference of event A and B. I write P of A, difference of P of B. Then after apply the condition of probability cases in the formula, we know the condition P of A, condition P of A, condition of B is equal to P of A difference between P of B divided by P of B. This is a procedure to follow for the conditional cases. Okay, remaining thing we will see the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.